We've already discussed some basic concepts of area of triangle in earlier concepts of triangles in the earlier video. If you have not watched that, we strongly recommend you to watch that. In this video, we're going to talk about the area of triangle and also focus on the similarity and congruencies of a triangle. So let's look at the formulas related to area of a triangle. So there are basically three situations which would sort of give us three formulas that we can use based on the type of information shared or given. First, how to find area when we know the base length and the height. The standard formula, all of us know what is the area of a triangle: half into base into height, right? So what is base in this triangle? Is it BC? Am I right? If you think BC is the base, what I'll say is that's partially correct, not necessary that BC is always the base. Any one of the three sides could be base. It just depends on what is the height that I know. If I have to use BC as the base, the logic is what is the third vertex? That's A. I need to have a perpendicular line drawn to BC and I need to know the height, right? So the formula is half into the base BC into height to that base BC from the third vertex, that's height. Let me use it HBC. That will be the formula. Let's say I don't know this, but rather I know a perpendicular line drawn from B to AC. Right? Let's say this is height to AC and I know AC, then the formula could be used still as half into AC into height to that AC, right? So the fundamental definition of base is basically the perpendicular line drawn to which side is called the base, so that I can use that value. If I know HAC as 5 and AC as 6 and this as 5, I should be rather doing half into 6 into 5, not half into 5 into 5. This is wrong, right? Just because BC looks like the base because the triangle is sitting on it does not satisfy this being as the base. As I said, base is not defined in that way. The base is basically defined based on what height am I using, because the height drawn to that side length AC is 5 centimeters, let's say. So I need to use the base AC, not BC. So that's why it's half into 6 and 5 is the correct one, right? Be careful on that part. That's the formula, half into base into height. Now let's say I know two side lengths and angle between any two sides, right? Let's say there's a triangle ABC. I don't know the height or anything, but all I know is this is 5 and this is 6 and this is sine 30. So then I can still use this formula. I cannot use this formula because I don't know heights, right? So what I can do is this: half into product of two adjacent sides that is next to each other into sine of angle between the sides, those two sides, between two sides, right? 5 and 6 are two adjacent sides next to each other and the angle between those two sides is 30. So the value will be half into 5 into 6 into sine 30, right? That's how we'll do it. If I know this and this angle, I'll apply this and this. But if I know this to be 60, I should not be doing half into 5 into 6 into sine 60. No, that's wrong, right? Understand, it should be two sides adjacent to each other. Anyway, any two sides are adjacent in a triangle, right? This and this is also adjacent. This and this is also adjacent and this and this is also adjacent. But if I am taking these two, I should use this angle. If I am using 5 and this, I need to use sine angle A. If I am using 5 and 6, I should use 30, right? Accordingly, you have to select that angle between them, the sine of angle between them. The third type is when I know only sides and I don't know anything about the angles. When I know the side lengths being, let's say, 3, 4 and 5. Okay, this is a right angle triangle actually, 3, 4, 5, 5, 3 and 4. So the area is half into 3 into 4, right? Why? Even if I use this formula, right, half into base into height, if I take 4 as my base, what is the height? This is the perpendicular line drawn, which is because it's 90 degrees. Half into base is 4 into height is 3, that's why answer is 6. Even if I apply this formula, I use half into adjacent sides 3 and 4. Sine of angle between them is sine 90. I know sine 90 is 1, so it will be half into 3 into 4, that will be again 6, right, which is what we did again. Now let me show the same thing using this formula. That's called Hero's formula. The area of triangle is S into S minus A into S minus B into S minus C. If I know all the three sides are A, B, C, I'll use this, where S is semi-perimeter. That's basically perimeter sum of sides by 2. So applying this, right, what is the semi-perimeter for a triangle of 3, 4, 5? 3 plus 4 plus 5 by 2 is 12 by 2 is 6. Using this formula, it will turn to be square root of S is 6. into 6 minus 3, s minus a, 6 minus 3 is 3, 6 minus 4 is 2, and 6 minus 5 is 1. So this will turn to be square root of 6 into 3 to the 6, square root 36 is 6, which is the answer, right? You're getting the same answer. It's just about what information is being given so that I can apply the relevant formula to get the area of the triangle.